image classification using deep learning model. I'm Devashish. I'm just want to describe the classification of COVID-19 positive and negative patients from X-ray images, which I build and build here with the CNN model in Python environment. Aim is to identify the COVID positive and COVID negative patients and based on the X-ray. So we used Python notebook and explore the data frame and Python. Now, perform the transformation of images from resize it to 100 by 100 and grayscale and perform normalization, split the dataset into training and test, and then create a CNN model to classify COVID positive and negative patients. We also perform test model evaluation and performance rate. Let us see these things in coding environment. Just let's go. Okay. Imported libraries. Okay. This is the data set. See, first part, I would like to create the data set for this images, because the images are received in two folder. So now one is for COVID negative, one is for COVID positive for my testing purpose. The packages required to import is NumPy OS CV2 and Matplotlib. So I'm parallelly running these blocks so that we can visually check. Here, one category as category is a constant. We kept as a two category. One is COVID-19 negative, another is COVID-19 positive. It's a list, and given the directory name, you can and keep your own directory where you are keeping this images. So this is let me run this. This is the image processing block. First of all, we'll see whether this is working fine, and we will go for the bulk image processing. So it is working given the path of the images, and then we read the image with cb2.imread, and we converted this size of the image, and also we change it to grayscale. Now this is the same as this block, but we can now put it in a for loop, which will run through all the categories, both the folders, and will convert all the images into our defined size and the grayscale. So I'll run maybe a little bit of time. Let it run, but we also created here two empty list. Here, what we would like to do, actually, one X in X list, I would like to put all the features, and in a Y, I'd like to put the levels. Levels I have derived from the indexes of the categories here. So levels is a category that index of this. So zero is the COVID negative images, and one is COVID positive images. So there are two classes only, 0 and 1. One is COVID negative and another is COVID positive. This block actually it is changing all the, yeah, so it's taking time. We have to uh, there are some coming. Yeah, yeah. Okay. Now we run this and while second we will separate this features and levels from here. Then we'll convert this x and y into an NP array. This is an important step because we are aiming for the tensor flow, so we have to convert it into NP array. Now we can check the x dot shape. So there are 2,271 images, and the shape is 100 by 100. Okay. Now, so we made the data. Now we have to save this data in a pickle folder. So we imported pickle here, and then dumping this data as a pickle file. Okay, that's all about data creation. So we have created the data from the images. Now we'll go to the second step. It's the training of this data. So first of all, we have to import this pickle file we stored, and for that we have to first import the pickle packages in this notebook. Let us go ahead. Now pickle, we have to load this pickle file with the pickle.load. We check y is this 0 and 1 is correct. Now we have to normalize x data because normalizing is very important. Otherwise, it will not correctly detect. So we know that it's a single channel now. So we can divide ax by 255 for normalization. Then we can reshape it for using CNN. We require an extra field here. Now let us import TensorFlow. So we are importing TensorFlow as a TF. For that we have for this project we actually made an environment, and we are uploading all these things into that environment coding, project coding environment. Now after we import TensorFlow, we'll import Keras from TensorFlow, and then from TensorFlow.keras model, we'll use sequential to sequence all the module flow, and then we'll use the con 2D max pooling, dense, and flatten, dropout, and activation. Okay. So here is the main structure of the CNN. We use model equals to sequential, means it will go on sequence. Model dot add. Uh, first is convolutional layer con 2D with 64 neuron. Filter size is 3 by 3. Activation is below. And then after we used max pool 2D with 2 by 2. Second, we used model dot add another convolutional layer of on 2D, say 32 neuron and 3 by 3 filter. Activation is relo, and same max pool 2D is 2 by 2. Then we flatten these things outcome. After that, we use dense layer, 128 neuron. Input shape is same as x dot shape from one to all 11. So we can see here is the shape. Activation function is relo, and we use dropout of 50%. The next layer also we use dense 128 neuron, and activation function is relo. Here also I'm dropping out 50% neuron. The next layer we use dense again, and 64 neurons. Activation function is relo, and dropout is 50%. And the last layer, actually this is the output layer. So we have two categories. We used dense with 2 neuron, and then activation is softmax here. From sklearn, we sklearn dot model selection we got, and train test split to split the train and test data. Model dot compile used for the compilation of model, and optimizer we use Adam, and loss is sparse categorical cross entropy. Metrics we used accuracy. Let me run these blocks. Some error has occurred. Now we'll use model.fit on train data, and train target, and epoch is equal to 15. So then this will take some time. So it will take some time, and let us now go ahead. So we can see that this accuracy is gradually increased, and now this 15 out of 15 work is in progress. After that, we'll read the test data, and then we'll save the module. Yes. That's good. And we'll save this into the COVID money file. Okay. Okay. It is written now. Now we'll go into the third step. Okay. In this notebook, this is a prediction notebook. So here we have to import these two packages, CB2 and TensorFlow. So CB2 is I need to change this environment. So okay. Now we import it. Yeah. Now is that the these are the files. We need to do the same kind of image processing here also. And now we'll go for prediction. Let's see. So we can run this prediction now and see that predicted correctly COVID-19. Okay, we can check another image from uh, COVID positive folder and say suppose one. It has been very. So let us see that. It's 0 or 1. Okay. So thank you for watching on these things, and please like, share, and subscribe my channel, and I'll continuously update new videos regarding this end-to-end projects of data analytics and visualization. Thank you.